In this video, I want to talk about another pattern for derivatives, a very important pattern. And this time I'm not going to work through the limit proof. I'm just going to state the result and do lots of examples. All right. I would encourage you to try to grind through the limit, find an example of it worked out, but it gets pretty tedious. So I'm going to leave that as an optional exercise, optional investigation. All right. What if? Here's the question: what if you wanted to take the derivative of a product of functions? Okay, like x squared times the sine of x, or the square root of x times cosine of x. All right, so we want to, in general, what we want is we want a derivative formula for function times function and the derivative of that whole thing. All right, so here it is. What you do is first function times the derivative of the second function plus the second function times the derivative of the first function. That's the way I say it in my head. First times derivative of the second plus the second times the derivative of the first. And I wrote it, the second term, in the order that I did, but there's the order doesn't really matter. So you could write it, put the g first and then the f prime after. Take your pick. Okay? So that's what we're going to use here. Now that's what we're going to do lots of examples on. Okay, so let me do now the first example. We're going to use the power rule we learned previously and the derivative of the trig functions we learned previously. Okay, so let's see, I'm trying to get some room here. Okay, so x squared sine x. So the first times the derivative of the second, which is sine, plus the second function, which is sine, times the derivative of the first. Derivative of x squared is 2x. All right, clean it all up. We get x squared cosine x plus 2x sine x. All right. Now, what about the second example? Now, you might say, hold on, we never discussed what the rule is for the derivative of a square root, or maybe we did, maybe you forgot. The point is, you can always rewrite the square root as x to the 1/2, can't we? All right, now why would that be such a good idea? Well, because the power rule for derivatives is so simple and easy to remember that if we can rewrite something as a power, that's usually a win. Okay, so I'll do it that way. And so again, first x to the 1/2 times derivative of the second plus the second times derivative of the first. Now using the power rule, bring the exponent down, subtract 1 from the original exponent, gives that. And then last step is usually cleaning up the mess. So if you like, you can go back to square root. Doesn't matter if you think it looks friendlier. And plus cosine x over 2 root x.